Hello everyone, my name is Anjana and today I'll be talking about designing a stall prototype for Gandhi Street Market and how we can improve the living and working conditions of not just the vendors but also the customers. The area of the research, as you can see, takes place in Trichy, which is in south of India, and it is a predominantly hot and humid climate and it's prone to extreme heat and rainfall. Usually between the months of November to February, you have mild climate. June to October, you have hot, and March to May, we have extremely hot. And the humidity ranges from 55 to 80%. As you can see from the images, the market is quite chaotic and unorganized and often crowded. Vendors carry out their businesses in semi-permanent stalls or makeshift platforms, and they sell their perishable produce like fruits, vegetables, and even flowers. If we look at the way of life at Gandhi Market, it has a very distinct character wherein the market functions from 3 a.m. in the morning to about 1 in the afternoon. It's only because their key clients are local store owners, chefs, restaurateurs, caterers who buy everything wholesale. The day of the vendor starts at about 3 in the morning, and at half 3, they set up their shop and they go to the nearby refrigeration facility, get their produce, and start displaying it. And about 5, their business kicks off. They also get breaks in between and they resume selling till about 1 in the afternoon. Vendors, as you can see, mostly sit on the ground or makeshift platforms. And because you're seated on the ground, there is a lot of heat exchanges from the ground. Even the produce is displayed mostly on the ground, and the vendors said they often sprinkle water to keep them fresh. Towards the end of the day, they would transport everything to a nearby storage facility, which also proves to be expensive for them. Therefore, as you can see, the perishable produce is exposed not only to the harsh weather conditions, but it also reduces their shelf life and an increase in organic waste. Fieldwork was taken place to understand their current working conditions and how their environmental factors affected their productivity and their own personal adaptive strategies to improve thermal comfort. All this was done through spot measurements, observations, interviews, and surveys. Spot measurements were taken in the form of air temperature, relative humidity, surface temperature, and wind velocity at different spots in the market. And this was done in July with an average temperature of 35 degrees and a relative humidity of almost 60%. Air temperature was also measured under various canopies that were commonly found, like gunny bag or jute, thatch, and commonly found um, other materials were plastic and different colored plastics. Plastic was mostly preferable as a canopy because they averted rainfall, and thatch and gunny bag was also preferred because it was readily available and quite cheap. As you can see from the readings, the gunny and the yellow plastic canopy was found to be cooler than the thatch and the dark colored canopies. So after all these findings, we found the major issues and concerns to be overheating, no thermal relief for customers, refrigeration and transportation, which proved to be a big cost for them, flooding as well. Strategies were also designed. Um, so there were two strategies that were designed in the design development. The first one was to provide appropriate shading and rainwater harvesting. Um, because of the nature of the market, it functions between 3 in the morning and 1 in the afternoon. We studied the different sun altitude ranges, which ranges from 10 degrees early in the morning to about 80 in the noon. And accordingly, we tested out different geometries to minimize the solar radiation. We even tried tilting the vertical plane to reduce surface area on the ground exposed to solar radiation. I also extended the roof outwards to block the solar radiation by 50%, and also this was to provide thermal relief to the customers um, during rainfall or during extreme heat. Um, a butterfly roof was designed to harness the potential of the rainwater as well as solar energy through PV panels. And then the roof was doubly ventilated to remove heat through airflow and also reduce the temperature of the overheated PV panels. We also elevated the stall to decrease heat gains from the ground, and the lateral sides were kept open for unobstructed wind flow. The second strategy was the preservation of perishable goods using passive refrigeration. Here we did devise an ecological cooling container that uses zero electricity to display and refrigerate their perishable produce. This device uses terracotta, which is traditionally used in India to keep the water cool through evaporative cooling. So how it works is the surface of terracotta absorbs water from the inside and forms tiny droplets on the external surface of the terracotta that comes in contact with air and evaporates, thus keeping the water cool. The passive refrigerator, as you can see, is divided into two chambers. The top chamber, which is mostly for display, has a chamber filled with rainwater and therefore keeps the surface of the terracotta cool and therefore keeping the displayed produce cooler for longer periods of time and extending their natural freshness. The second chamber has a cavity-lined terracotta filled with water again, and this is for refrigeration. This concept for the bottom chamber has been inspired by Terra Cooler, which is devised by Stephen Augustine for food preservation and uses evaporative cooling to store and produce in a cool environment for a longer period of time without the use of electricity and transportation. To conclude, the stall prototypes could be used in many other places with similar climatic conditions, and these strategies not only provide effective shading and ventilation, but also decrease the cost of living and also promote a better lifestyle. This will ensure that the humble market is still competitive, relevant, and environmentally friendly in this alternative, fast-paced world. Thank you.